Last question first. Don't take your time. You have 10 minutes to attempt the question. Then I'm going to discuss the answer straight away, guys. Okay, since we're on the last month before you guys go for exam, right? And then I'm going for the OTA for sure. Guys, please, this is the last month where you go from zero to hero, guys. For those who have not done any past year papers and you are still not kanjiang one, I highly recommend that you start doing it right now. As you do more and more, you realize that it becomes easier and easier, guys. Don't give up on physics because physics has not given up on you yet. Okay, with that said, please continue doing your work. We'll discuss the answers in exactly 6 minutes. Yeah. Don't worry, you do your question first. Then after that, if you have any questions, you just let me know. Can you take a picture if you have any questions? We'll be focusing on the what's it called? The non-core paper, the extended paper.你们全部有出去啊？等一下，怎么你剪个那头你？你装可爱啊你？You do the 2018 paper same year as them, October, November, just that is the core paper instead. 快点做啊，聽你講咩啊？
What is this question asking?
They're asking you to show whether there are alpha, beta, or gamma rays here based on the count rate. Do you think there will be alpha, beta, or gamma here, and explain why?
And how do I know if there is? How do I know if there is any alpha, beta, or gamma?
Based on the materials that are blocking it. Bạn什么球？几号点？星期几？星期四啊。明天啊。9点到12点。9点到12点不可以，我有饭想。 星期四啊，你们讲真的吗？真的我就 rearrange 我的 class 去打。星期二或者星期四讲好来。星期四或者星期二讲好来。
有2天。
哦，2天都有打，明天你们有打。OK， 我得今晚跟你讲，我去 rearrange。confirm 拿哪里？普渡打badminton。
我们将来星期四啊。我明天是哪里？明天是
这里靠近啊，这里靠近那边啊。哦，星期二，明天。明天是哪里？
那个去我打那个币。
OK， 明天我 join 你们。9点啊。OK。
我们在你 location。
在我 location。
我们7点半。
No， 那个不对 ，sorry。See you for badminton。喂，你们讲真的嘛？不要容易说。几多个人现在有？等一下跟他讲。
对，我们总判的，在哪里吗？明天到。
我是讲明天。Alright, guys, shut up, pay attention. Let's go for this question straight away, already, guys. For sure, a lot of you guys never do, but it's okay. Very good. Okay, now pay attention. Our first information they give you, figure 11.1 shows the data about 9 elements, whatever this is, right? Carbon 14 is a radioactive isotope with a nucleon number of 14. Straight away, they give you the nucleon number, right? So it's carbon 14 with a nucleon number of 14 here. It decays by emitting a beta particle, okay? So first things first is you have the 14 nucleon number, you find from this graph where is the proton number, which is essentially this 6 here, right? From here, because it goes through beta decay, that means to say it's going to be 14,6. Then make sure you draw the arrow to indicate that it goes through decay, right? And beta will be electron 0, -1, guys, plus with whatever that you have left, it's still going to be 14. Here is going to be 5 or 7. It's 7, guys. Always remember it's 6 minus 1 from here. And after that, it's going to be your N. And for this simple thing here, you get 4 marks. There are some of the previous students from Wesley, they keep asking me how to get the 4 marks, how to get the 3 marks and everything. Guys, pay attention. The marks are not important. Make sure you know the concept and answer whatever is in your head. Then that's good enough already. Most of the time, the marks don't correlate to the amount of work that you're supposed to be doing, guys. So don't care about the marks. Just make sure you get everything. That is 4 marks here, guys. This is your first equation. I think at least 70% or 80% of you guys should have gotten this correct, right? Then moving on to this next part here is the one that is a little bit more tricky, guys. What is N? N is the nitrogen here from the 7. This nitrogen here. Oh, yeah. Because you're supposed to find this using this, and you find that it's N. So you know what symbol to use. Yeah. All right. Then after that, this next question here is the one that is a relatively more confusing part, guys. It says that a radioactive sample is placed close to a detector. The radioactive isotope in the sample has a long half-life. Means to say it's damn stable when it has a long half-life. The detector records a... Am I recording? This detector detects records a count rate of 559. Sorry, 97. Sorry, 597. I tell you, my brain is getting a bit haywire. But anyways, figure 11.2 shows the reading when the different materials are placed between the radioactive sample and the detector. When a sheet of paper is present, not only did the count rate not drop, it increased a little bit. when there's a thin sheet of aluminium, the count rate increased again. Then when you put a thin lead, the count rate dropped a little bit. Now, first question, guys, why do you think these two, the count rate increased slightly? What's the reason? Pass through, but initially the count rate only had 597. Yes, this is due to background radiation. Guys, the first information you're supposed to understand here is the reason why the count rate increases is because background radiation fluctuates up and down, right? If it fluctuates up, it means to say these two materials here are completely useless in absorbing this radiation, right? So from here, first things first is I know that if sheet of paper and aluminum doesn't work, I know that alpha and beta is not present already, because if they were present, the count rate would have dropped more, right? Right. So this is the first thing I have in mind. Then after that, I noticed that the thin lead, the count rate drops to 510. It dropped by 87 counts. Why did it drop 87 counts? Is because this thin lead here is not sufficient enough to block everything, right? Because it's too thin. It only absorbed 87 of it. Meaning to say, I know for a fact that gamma radiation is definitely present here, right? So when I have this information in my head already, this is how I'm going to explain it. Is there any alpha particles present? No, no alpha particles present. Why? Because the count rate should have dropped when the sheet of paper was supposed to be there. If there's alpha radiation, of course, you put it in proper words. I'm going to say something like, if alpha particles were present, the sheet of paper would have dropped the count rate from the detector. Or any way you want to word it, guys. It's not important how you word it. The concept is the one that is important here, guys. You need to know whether it is present or not, right? Same thing for beta as well. Is it present? No. Why? If beta was present, count rate would have dropped with the thin aluminium. And finally, is the gamma ray present? For sure. Yes. Why? Why is it there? Because the count rate dropped by 87 counts per second. Counts per second, because the thin lead only absorbed a fraction of the radiation. It's not thick enough, basically. These are supposed to be your answers, guys. But you don't have to put it, you don't have to go by word, guys. Like I keep saying over and over again. Just make sure you have the concept in mind, then you can answer it. Am I going to be serious here? Maybe.
So when are you going to get like this?
Oh, I have the screen already. We're gonna install it tonight.
Oh, opening ceremony.
我要剪彩耶！
我
有看到我们的
PPT 的好看到。
Hurry up, copy this now. I want to go to the next one already. Okay, done. Anyone's got any questions from this part? Hey, this type of question comes out a lot, guys. You have to know how to answer it. Whether it is a yes or no. Usually the dead giveaway is alpha will be a sheet of paper or anything, right? Anything, even paper is enough. Beta will be aluminium or wood, as long as it's thick enough, and then lead will usually be gamma. These three things are usually. Yeah, ionizing alpha is positive too. So it is alpha is the strongest ionizer. Huh? Penetrating is gamma, yeah. Okay. If you're done, go do question number 10 right now. 10 minutes as well, guys.
你聽我，係我面，
好不？
好嘛？我要不佢就，
不多一个，几多个人去
是你會打嗎？
？OK OK 啊，不会很差哦，不会很紧哦。OK OK 啊，Let's see tomorrow。有谁代表学校的吗？你们
Marcus 代表 state 的 role，
？Really 啊
你現在什麼了？
？State 我应该打不赢啊，But normal 玩的 OK。
係會肥的哦。唯一一个。
像我 location 来玩。
有啊，因为我们啊，然后天分就有差。
Oops, JJ, I just saw your message. Yeah, you're supposed to do this one.
这个中国是吗？因为
对啊，一个。我们要3个手，我们好像怎么上班这个1个小时啊？要不你看这个应该有，是我可以上 online 有 EP
什么
EP 上 online 有指教啊
？Online 什么？
啊，你是啊，还可以教吗？那个想法的 EP 这是我应该有吗？
喂，快点说。
哪个？我够，不是号啊，你要，你看看，啊，我也是不感觉，你有这还听说我们就是一个没有，一个啊，啊，对啊，可以，我看这以前，我在给他看到，那个152，你说42，你这几个，那个项目，哦，你不是。哦，老师，我知道你们是属于哪一种，
不要。Yeah, good question 10, Sydney.
啊，他这里有一个，对啊，一回来就变成你的那个什么妹夫哦。第三是什么？我那个，我，没plan了。我知道，现在就3个人妹妹。 Hey, no. Okay.
喂，快点做啊，不要吵啊！No，
我看要不要？找一个，我还有一个。都一样哦。没有上来毛病，毛病可以多，没有上毛病，对，另外的话是在也蛮痛惜，然后还讲了，already 有高来了，两个高，什么啊？哇！啊？诶，像反正
我可以给他50片的重复疗
哦啊，
你这里
好，哦，在那个店的那个照片啊，这样然后我们师傅出现嘛，我们上面以为我们左。
Guys, for those who are done with question 10, you can start doing question 9 instead of playing with your phone, guys. Okay. Try to do everything as quick as possible, guys. Okay, guys, let's go through this question together real quick, guys. If you look at this question here, first things first is they say that a transformer consists of 2 coils of wire and a metal core, right? Figure 10.1 represents the transformer. What is the metal that the core is made of? It should be iron, guys. Always remember that iron is the one, soft iron, to be specific. Iron. Stainless steel some more. No. Hey, listen up, iron is the one that is the temporary magnet, steel is the one that is made from permanent magnets, guys. Always remember this, you wouldn't want a permanent magnet on this core, would you? Right, so it's supposed to be soft iron core or anything iron that you want, right? Right. Then the next part here, guys, this is important. You see here, this 3 marks here. Usually, if it's a transformer question, guys, if it is transformer question and it give you more than 3 marks or 4 marks, right? Most of the time, it will be explaining how a transformer works. If you're supposed to explain how a transformer works, in this question here, they ask you to explain why there is a voltage between the 2 terminals in the secondary coil. You're basically supposed to understand how is the voltage created, guys. It's always starting off with the primary coil connecting to an AC power supply. This AC power supply will supply an alternating current, which will generate an alternating magnetic field that is constantly cutting through the secondary coil, guys. And because of this, when there's a magnetic field cutting through the secondary coil, electromagnetic induction occurs and thus produces an EMF in the secondary coil. It's always going to be with this sequence of the answers, guys. You need to know how a transformer works, guys. So if you written down something and say that AC power supply is connected to the primary coil, which produces an alternating magnetic field. This alternating magnetic field conducts through the coil, through the iron core, and cuts through the secondary coil. Electromagnetic induction occurs and EMF is produced. Something along these lines. It doesn't have to be word by word, guys. It will be good if you have a whole idea of how the whole thing works in your head, then more or less you can bullshit your way through. But if you see transformers more than 3 marks, most of the time it's either going to be this or the current in the wire one. Remember the current in the wire one, you want to have high voltage and all those kind of things, right? That would be the second 3-mark question for transformers. Wow, suddenly got dead silence in this room. Okay, then moving on to the next part here is basically calculation, guys. This is basically the number of turns in the primary coil. This is basically a number of turns in your secondary coil, and this is the voltage in your secondary coil, right? What's the formula here again for transformers? VP over NS. Vs is equals to NP over NS in this scenario here. It doesn't matter which way you remember it, but just remember that it's in terms of ratio, right? Then if you put everything in this formula here, it will be like VP equals to NP times Vs over NS, right? Which you yet again put every number in. 560 multiplied by 78 divided by 910. Press that in your calculator and you're going to get a very weird number. How much is that? 48. 48 volts, guys. Make sure you write your units. Okay. Okay, Then moving on to this final part here, the transformers are used to increase the voltage when the electrical energy is transmitted a cable in the long distance. Explain why power loss in the cables are lower when the voltage is the same. Guys, this one here is the same concept like we mentioned, guys. Whenever we're transporting voltages, especially from TNB to your house, which is at least going to be 30 kilometers far away, guys, we'll usually choose to transfer the energy with a high voltage and a low current. Why? Why do we want a low current and high voltage? What's the concept here? Sorry? Say that again. Yes, correct. You're supposed to have less heat loss when the current is lower, guys. Because if you imagine a wire, guys, when there's a less current, means to say there's a less electrons flowing in this wire, right? And these electrons are basically going to have friction against the internals of the wire, which is going to generate heat. With a lower current, less electrons, less heat generated, means to say less heat is lost to the surrounding. And ultimately a higher power efficiency, guys. It's going to be a higher power efficiency. Alternatively, you can also explain it in terms of the formula of power. You know, power equals to I square R, right? When you reduce your current, guys, what's going to happen is your power is going to reduce even more. Your power loss is going to reduce even more. So you can answer in either way. For me, I'll say that since power is the same, a higher voltage means less current in the wire. Less heat is lost to the surroundings, increasing the efficiency of power transfer. Or you could even write something like according to P equals to I square R, P equals to I square R. A decrease in the current helps reduce power loss over a long distance. Anything along the lines, doesn't have to be word by word. Yeah. All right, guys. Any questions for this part? Hey, very important. These two you must know. If they ever ask about a transformer, how a transformer works and why a lower current is preferred is always asked in your exam, guys. If they don't ask about calculation, but this question here, they ask about calculation and the two theories. So it's a combo of everything. Right. Okay, if you have no questions, start doing question number 9, guys. Ten minutes again. Let's try to do as much as we can. Oh, sorry. Okay, guys, let's go through this question now. Quite a short one, guys, but yeah. So if we look at this one here, what does it say? Figure 9.1 shows the symbol for a 12-volt battery here. This is the battery. Two lamps are connected in parallel with the battery, guys. And I ask you to use the correct symbol to complete the circuit diagram, guys. If you just need to draw, right? I don't think you even need to draw the switch for this one here, guys. Just draw the two lamps that are connected in parallel to each other, right? And you have gotten your free one mark, right? Quite straightforward, quite easy. Then after that, the next part here, one of these lamps have a resistance of 6 ohms. Okay, so there's 6 ohms here. Calculate the current for this lamp. If I want to calculate the current here, guys, I want to find the current, right? I must have the individual voltage and the individual resistance, right? If they are connected in parallel, guys, remember for parallel circuits, they all share the same voltage, guys. Being to say, I can use the V equals to IR formula here, right? V equals to IR, I would have been equals to V over R. In this case here, it will be 12 divided by 6, which is going to give you 2 amperes exactly, guys. You're supposed to get exactly 2 amperes here, right? Then after that, the next part here, they ask you for the power. Power, you could use either one of the formulas, guys. You could use power equals to VI lah. You could have used power equals to I square R lah. You could have used power equals to V square over R. I'm pretty sure all of it will give you the relatively same answer, guys. And from here, obviously, I'm going to use the easier one. P equals to VI, right? In this case here, it will be like 12 multiplied by 2, which is going to give you exactly 24 watts, guys. You make sure you write your units here. Then next part here, they say that the power of the other lamp is 36 watts. Calculate the total energy delivered to this lamp in 20 hours. First information is, I know that I'm supposed to calculate energy, right? Energy's formula is E equals to VIT, guys. E equals to VIT, okay lah, I have the voltage, right, which is 12. But I don't have the current, right? I do not have the current, and the time is not multiplied by 20. The time is always in seconds, so it's 20 multiplied by 60, then multiplied by another 60 again. Yeah. Right. So how do I find the current here? You know, to find the current yet again, I need to use this information here. They say that the next one is 36 watts, right? So this here is 36 watts. Using yet again the P equals to VI formula, guys. Oh, actually, I didn't even need to do that. I can straight away use the E equals to power times time formula, and I got the same thing. Yeah. Sorry, my bad, guys. This is essentially going to be power already, guys. So it's energy equals to power times time. In this case here, straight away 36 multiplied by 20 multiplied by 60 multiplied by 60 here. Right. And we press that in the calculator, you'll get how much?
2.59 times 10 to the power of
6. What's the units?
6.
Joules. Let's look at joules, guys. Yeah, 2.6 is acceptable as well. You can only write up to a minimum of 2 significant figures and a maximum of 3 significant figures, guys. Remember that. Yeah, relatively straightforward question, guys. Anyone's got any questions for this part here? If no, please continue doing the next one before we end the day. Or if you try to squeeze one more in. Hey, let's try to squeeze one more in. 7 minutes this one. Huh? Oh, we're throwing eggs later.
Later when?
The next class.
My
next class will be
oh my gosh. I throw your
Okay, do this next one. 7 minutes, guys. Okay, guys, I assume everyone is done now with this question. Let's try to squeeze in one more question before we end the day, guys. Now, guys, if you look at this question here, it's a very common IGCSE question. They want you to explain something called a longitudinal wave. A longitudinal wave, you all know what it is, right? A longitudinal wave is that thing with the compressions and refractions, right? Whatever information that you have in your head, just write it down only. You're going to say that, first and foremost, you're going to say the vibration and propagation are perpendicular to each other, and you're going to say that it has something that are compressions with, sorry, what did I say? It's supposed to be parallel, not perpendicular. Yet again, brain having problems already. Guys, this is basically a compression where it is a region of higher pressure. That's why molecules are closer together. And this is what we call a rarefaction, where the region pressure is lower. That's why the molecules are further apart. You're supposed to say all these things into this question here. So if I were to write this down, I'll say that longitudinal waves are waves with vibration parallel to its propagation. Guys, if you cannot remember the word propagation, you can always say the direction of wave travel is the same thing, guys, right? It has compressions where pressure is higher and molecules are closer, closer together, and rarefactions where pressure is lower and thus molecules are further apart. Right, everything you know about longitudinal wave, and you're going to get your free marks. Direction of wave travel. If you cannot remember the word propagation, you can always write the word direction of wave travel. Yeah, oscillation parallel to the direction of wave travel is acceptable as well. It's the same thing, guys. Like I keep saying, it's not an English exam. This kind of question comes up very often, guys. Make sure you know how to explain it. If it's a transverse wave, then you say everything also, right? It has a sinusoidal wave with peaks and crests, and the vibration are perpendicular to the propagation. And you get your 3 marks. Yeah. Okay. Next. You're basically asked to find the frequency is this amount, the speed of the wave is this amount. All right, oh shit. Then state the typical value for speed of sound in liquid. How much is this one? 1,500. Very good. Right, guys, remember it's always going to be 330, 1,500, and then 3,000 for air, liquid, and solid. Guys, you need to remember these numbers because they will always test you on these kind of questions, guys. Yeah, and then you get your free 1 mark here. Easy. And finally, the last part here, using your V1 and blah, blah, calculate the wavelength. V equals to F lambda, guys. Wavelength would have been V over F. In this case here, it will be 330. Oh, sorry, in the ocean. Sorry, it's going to be 1,500. Divided by a frequency of 800. Right. Then press this in your calculator, you're going to get 1 point something, 1.9 something. Most likely. Yeah. 1.875. 1.875. So it's 1 per bar. And meters away, guys. It's supposed to be meters. Okay. Hey, one more question before you guys go. Is this a long one? Let's see. Oh, good. Okay, I'll draw this for you guys. Is everyone done copying or not? I'll do the last question for you guys.
Yeah.
Anyone online not done copying with this? Eh? I'll do the last question and show you guys how to do the drawing, guys, because usually it's not included in the mark scheme. Okay. So first question, what do they want from you? A laser produces a beam of monochromatic light. Straight away, I see monochromatic light, which is like lasers, right? State what is meant by the term monochromatic. You're going to say waves with single wavelength and frequency. This is your definition of a monochromatic light, guys. Unlike white light, which has 7 wavelengths, monochromatic light only have single wavelength and single frequency. If you write either one of it, it's acceptable, right? Okay. Okay, and then next, a wave in air is incident to the glass block. Okay, figure 7.1 shows the wavefront of the air glass boundary. The arrow shows the direction of the wavefront here. Right, so they're saying that this wave is traveling here, right? And if it's in air and glass, most likely this is going to be a light wave, right? Then from here, the light undergoes reflection and refraction at the air glass boundary. First and foremost, they ask you to draw the reflected wave. Guys, when you draw the reflected wave, you know you're not supposed to just simply hand thumb and draw. You're actually supposed to use your ruler, draw all the way until here, draw your normal, which is 90 degrees here, measure this angle and reflect it. This is not finished yet, then only you draw the wavefronts, guys. You're supposed to do this, you draw until it hits the glass, then you draw your normal, measure the angle, measure the same angle, draw the direction, then only you draw your wavefronts. This is how you're supposed to do the reflected one. Right. And then after that, you're going to draw the refracted one. Oh, you understand what I'm talking about, Natalie? Yeah. Right. And after that, you're asked to draw the refracted one instead. Oh, some of you guys are still drawing the reflected one. Hey, hurry up, draw the reflected one and draw your wavefronts the same distance, because reflection does not change the wavelength. They should be the same distance to each other, guys. Hurry up. Just draw. Just draw. Your wavefronts, one more thing, your wavefront should be perpendicular to the direction of your distance. To the angle of your direction. What? Your wavefronts should be perpendicular to the direction it is traveling in. Okay, and the wavelength should be the same before and after the reflection. Okay. Yes, I'm done and draw. Sorry. Wavefront should be perpendicular. Yes, it should be perpendicular to the direction it is traveling in. See, it's perpendicular here, perpendicular here. Okay. Then after that, you're supposed to draw the refracted wave. Guys, when the light ray enters from air into glass, will it bend towards or away from the normal? It's supposed to bend. Nani? Who was the one that says away? It's supposed to bend towards the normal, Vicky. Honey, because the speed of wave slows down. No way the light is traveling faster in the glass, right? Hello? This is the original path. Then it slows down and goes here. Right. Does it make sense or not? Right. So once you have this, then you just draw. This one you don't simply draw. This one you need to draw according to this one. So with this direction here, guys, listen up. With this direction here, right, you're supposed to draw perpendicular with these waves here. Then once you have this, you're supposed to draw this, and draw this, and draw this, and draw this. You don't have to purposely adjust the wavelength, because once you slant it, right, the wavelength automatically decreases, indicating that the speed of light has decreased as well, guys. Because yet again, it follows the V equals to F lambda. Yeah, just sketch, but the first one must be perpendicular. This one here must be perpendicular. Okay. And they should all be parallel, all these. But of course, I can't do it with my mouse. But you're going to draw it nicely. Wow, 3 marks and 3 marks are bloody hell. This is a free 6 marks here. Okay, then finally, the transverse wave is produced in a long horizontal rope. The rope is much longer than the wavelengths of the wave. In the space below, sketch a diagram to show the appearance of the rope as the wave passes through. Label 2 important features of this. You're supposed to draw the wave with a transverse wave like this. Right. It is much longer than the wavelength, meaning to say it can go, it must at least be 3 wavelengths, guys. This is 1, this is 2, this is 3, right? You can draw 4 if you want. Then after that, 2 key features is either the peak or the trough or the amplitude, right? Or the wavelength. Either one is acceptable. The crest is the peak, yeah. Crest and peak are the same thing, Crest and peak are the same thing. The trough, or however you pronounce it, trough.
If I label like 4,
you will not be penalized, but if you do not label 2, you will be penalized. Okay. Yeah, you can just label it as the equilibrium. If you don't draw the center, you cannot draw the amplitude though. Oh, then no need. No need. If you label crest and trough, then you don't have to draw the equilibrium, because that's the 2 things you need already. Okay, everyone, please, before we end class, I must emphasize that you better start panicking right now. And for those who have not been doing past years, you better start doing it right now. Guys, you have 1 more month before your exam. It's time to go from 0 to hero. Okay, having said that, we end the class today, guys. Sorry? The equilibrium position, which is just the axis. It's just the axis. Okay. Okay, bye-bye. Bye-bye. Welcome. Okay, welcome. Bye-bye.